Hello again, everyone. Last time we had to work with a function that's called remove the node. So we wanted to get rid of the nodes that we were not desirable in the network. Suppose an individual left a community, or an individual is no longer collaborating or unavailable, or somebody retired. So we wanted to make sure that we want to remove the node from the network. And one of the issues that we ran into last time, then when we tried to remove a node here, we only removed it from the set of keys, and it was removed and it was fine. However, the node was not removed from the values, because remember, this is an undirected network, and C connected to A is as good as A connected to C. So it doesn't mean if you remove C here that A and C will be removed. So we need to do better. We need to do what we basically did was a shallow removal of a node. What we need to do now is to do a little bit a better job, that we do a deep removal. And how do we do that? To make this an easy exercise for us, I think I'm going to put the object oriented aside, and I'm just going to focus on implementing this function differently now. So I'm going to define a function here called remove node, and I'm actually going to call deep remove node. And if we are defining a function that is supposed to be removing a node, we might as well make sure that we pass the node, and we might also need to pass the data structure, which is a graph in this case, which is also a dictionary, that we're going to be processing, and we're going to be iterating over, so we can search and remove the node if the node is found. The best way I know that can actually give you the quickest result for searching the keys and also searching the values at the same time is this way. Let me show you. For a key and a value in the dictionary, which is graph.items. So this is the magical function here that I want you to remember. This, every time you want to process keys and values at the same time, work with this magical function. It's one of the best, if not the most important function, I believe, in the entire Python programming, because dictionaries are very significant data structures. And this function makes the world truly amazing. And I will prove it to you right now. So now suppose we are searching for the node in the keys. How do we do that? So we can say if the key here equals the node, what do I need to do? I can easily remove using the delete function that we used here earlier. So I'm just going to use the graph object that I'm passing, and I'm also going to pass that node, or we can pass the key, it doesn't matter. We can pass the node right here. So that would be my first thing. So this is going to get rid of the key. And again, it doesn't matter which one you pass, because they are identical. The values are the same. Now I'm going to ask another question, and those two questions are independent of each other. If the node is in the value, and I want you to realize that the value here is a list. That's why I did not use equal equal. I'm using in because if we print the type here, it's going to give me a list. But we already know that this is a list because we can see it right here. So if that node is in the list, then we're gonna have to remove that node from that list. And the list here is signified by the keyword, or the variable, the arbitrary name called value. And then we can remove it, use the remove function that is built in as part of the Python list. And then we're just gonna pass the actual node. And if I've done this right, I can just return the dictionary after I cleaned it up from the nodes, from the node in the keys and the node in the values. And I would like to see if this is working or not. So let me run the cells one cell at a time. So I'm going to run the class, even though we're not using it yet, and then run the dictionary object here. So we know the dictionary is fully populated. and then I'm going to run this function here. Hopefully we didn't have any errors. Looks like we don't. And now I want to invoke this function here. And as you can see, I'm invoking the function without a prefix by a class name or an object name because it's already defined in the environment. I did not make it as part of the class yet. I will move it later on, but just for the sake of simplicity, I wanted to make sure that you see the function kind of independent from the graph, so it doesn't really confuse you. You don't get confused with all the logistics with the graph as well. But once we get this done, we are going to migrate it into the graph. Now, what I need to do is to specify a node that I would like to remove. And then we would like to choose a node that is both in the keys and in the values. So it seems like C here is in the keys and also in the value. A is the same story right here. And I believe some other nodes as well. D and D, and maybe F and F. So all of these are good nodes. So I'm just going to choose maybe, I don't know, maybe F. And again, I'm not being selective. I'm just choosing randomly here, and it should be chosen randomly. So I am passing this graph dictionary object to the function, and I'm supposed to be getting back the pruned graph, the graph that does not have the nodes that we gotten rid of. So if I run this, hopefully I won't have any errors. Okay. It seems like it did not really like us. Let me see. Maybe we should remove the value first. If we can remove the value first before the key, then it might work. Because the dictionary doesn't like the size to be changed in runtime. That is the issue here. So let me run this one more time, like that, and then run it one more time. And now I would like to print the pruned graph. And as you can see, we don't have any nodes that are labeled as F. None of these guys. So it seems like we've done a really good job here cleaning the graph. So how do I put back this function here into the graph? This is really simple. All I have to do is to copy this function like that, and I'm going to paste it here inside the class, and I gotta make sure that I have to indent it properly. And now I want to get rid of this. That's the truth of the matter. I want to make sure that I've gotten rid of it, and I'm going to rename this guy, this function, with the same name that I used before. But here's what I also need to do. I need to pass the self object because it's part of the, this is not an independent function anymore. This is a function that belongs to the class. Okay, and now if you remember, the class is already enjoying the pointer to a graph dictionary object. So we really don't need to pass another parameter here. All we need to do is to refer to that class, to refer to this graph. So I'm going to use self underscore graph like that, underscore, I believe. Yes, underscore graph. So I'm going to utilize this object here that is part of the class because I already defined an instance variable of type dictionary here. So that's the reason why I'm passing here the self, so the self can reference the dictionary object like that. And I think if there's no other reference, I believe there is, we need to make sure that we use the proper graph object, because now we removed the parameter we're passing here. We also need to return the self graph as well. So hopefully we did not make any errors. I wouldn't be surprised if we actually did. And if we run it, we did not have any errors. Okay, good. And I'm going to run the original graph as well because it still has the F letter here. I just want to make sure that the same impact happens. And now I have migrated this function here into the graph. So I'm just gonna remove it right now. Okay, so now what do I need to do? Now we migrated the function inside the class, so we have no choice but to construct an object of type network, and we need to pass the parameters that the constructor takes. It takes three different things. It takes a name, so we're gonna pass a name, and we called it collaboration network, if you remember. If you don't, just go back and read the and watch the last video. You'll remember. It's not important. So now the second thing, it takes a type, undirected, like that, and the third type, it takes the most important parameter, which is actually the dictionary data structure, and this is supposed to be giving me a graph, and we always call this collab graph. Excuse me. So if we've done this right, if I run it, we did not have any issues. Fantastic. So now let me get rid of this. Now I have, because I gotten rid of the function that used to be called deep remove, and then but we removed it, and now we migrated this function into the object, into the class. So this is irrelevant anymore. This is invalid. So what do I need to do now? I need to use the class object here, and then use the dot operator to invoke the remove function, and and then now I want to remove a node. So tell me what node that I need to remove. I can do the same thing we've done before, the F node, like that, and this is gonna give me the neo G, like that, then the new graph. And if I've done things right, I can here I can invoke the info function, and that could show me the number of nodes that we have. We used to have how many? 6 nodes here. So now if I this is supposed to give me less nodes, so let me do that. I'm gonna run, so let me remove this node first, and it seems okay. It seems like we had some difficulties. It seems that it doesn't really like that the function is embedded inside the it doesn't like that the dictionary is changing size in a runtime. For the time being, I'm going to reverse to the original function here. Let me go back here as a backup plan. So I'm going to just get rid of this here, like that. So the function here, this is my original function, and I'm going to pass another graph like that, and I'm going to get rid of the self dot underscore underscore, so we can make progress. And I will show you now how do we construct an object, how we populate this guy here without having to worry about the function being embedded inside the class. So if I run this, it seems like we are okay. The function seems fine. Now we're running the function as an independent function, I mean, and let me make sure that we still have this graph in memory, like that. So we have the 6 nodes. Now I want to remove the F node, and I want to remove it from the graph dictionary object, and this is gonna give me a new graph, like that. So if I run it, is basically telling me I am, oh yes, because we are not supposed to be passing a self here. This self belongs to the class, but right now we're leaning on the independent function. So let me make sure that, okay, we have some issues here. Yeah. Okay, so now if I run this dictionary here, I will see that I've gotten rid of the F function. Okay, how do I work now? How do I work now with this network here? Suppose that I'm not going to embed. Suppose that I'm not going to migrate this function inside here. How do I work with this new dictionary in a way that I can populate a graph that is let me do it this way first. We're not going to remove anything, but we're just gonna get information on this graph. Okay. What we need to do is to get the information here on the graph so we know what we're doing. This is the graph here, and I'm not sure why. Let me do this. Now it should give us 6 nodes. So this is the graph before we deleted the f node here. Now I'm going to run the remove function like that, and I'm going to remove the f. Again, it's just somehow it keeps doing this stuff for us. I'm not sure why. I'm gonna run it one more time. I don't know why it keeps doing this. This is one of the unpleasant surprises. Nobody wants to have some sort of interruptions like that. I tell you what, let me run this one more time. Again, it just keeps happening randomly. And if I run it here, now I've gotten rid of the F dictionary. I'm not sure why we needed to run it multiple times. But now if I take this guy here and I want to, I can actually, here's another interesting thing we can do. Remember, we have a function called set graph. This set graph here can actually take the network object, and if you invoke set graph on it, and then we pass the new guy here like that, this is gonna give me the graph populated with the new value. And I guarantee it to you, if we invoke this function here, the info function on this is going to tell me that I have less number of items. Indeed, 5 items versus 6 items. So the only issue that now we have to figure out is how to delete or how to remove items from the dictionary in both keys and values without having this runtime issue. So let's stop here, and I will do my own research and I will figure out what is going on with this specific function, why it keeps acting kind of inconsistently. Without, sometimes it works, sometimes it doesn't work. I'm not sure exactly why. But I will do my research, and hopefully next time we will be able to integrate this function inside the class so we can manage to invoke it from the network object without having to implement it from outside the graph and do all that long road to Moria. All right, so let's stop here. Let me know if you have any questions. Let me know if any of this is not making sense to you. And I'm happy to answer any questions, and thanks for watching.